Hi everyone, today I'm going to quickly go through all the different types of chemical reactions. Throughout the video you're going to see some of my demonstrations as well. So 5 different types of chemical reactions: combustion, synthesis, decomposition, single displacement, and double displacement. We'll start with synthesis. So synthesis is when 2 or more substances combine to form a new compound. So here we have A plus B forming AB, that couple here. If you want to balance this, we're going to put a 2 here. So here I'm going to combine magnesium and oxygen. The balanced equation is here. All right, for the first demonstration here, I'm going to do a synthesis reaction. And so to do that, we're going to combine magnesium and oxygen. Now this reaction needs a little help in the form of heat. So I'm going to modify my equation here and write the word heat above the reaction arrow. So now, let's see what this synthesis reaction looks like when I combine magnesium with oxygen with the help of some heat. Here's the magnesium metal. Next we have decomposition reaction. In a decomposition reaction, a single compound breaks down to form 2 or more simpler substances. The notes look much better on PowerPoint, so if we want to balance this one, it'll be 2, 2, and 1 there. So here we have a couple and they break up. So for my decomposition reaction, I'm going to do elephant toothpaste. So feel free to. All right, for my next demonstration, we're going to do a decomposition reaction of hydrogen peroxide. So this is what the equation looks like. Now, this reaction does not happen spontaneously. We actually need a catalyst to help this reaction get going. So I'm using potassium iodide, Ki. So I'm going to write that above the reaction arrow. Now this is the reaction that we're going to perform. And you may recognize this reaction. We've done it before. So I'm going to move it around because it's going to get a little messy here. So when I add the potassium iodide here, the Ki, then that should get this reaction going. So let's see what happens here when I add the potassium iodide. Ooh. Oh yeah. There we go. Science. It's still going. For those of you who remember, this is elephant toothpaste. All right, there you have it. That's the decomposition of hydrogen peroxide. Next, we have a single displacement reaction. So here, a single element displaces another element in a compound. So here it's an element reacting with a compound. And so what's happening here is the magnesium is actually kicking out the hydrogen. And if you wanted to balance this, we've got 2 hydrogens, 2 chlorines, so a 2 goes there. And so in this cartoon, you see this guy here replacing this schmuck. And so we call this guy Mr. Steal Yo Girl. All right, so check out the demonstration. Here I'm just using aluminum with some copper chloride. And this is a single displacement reaction. In this reaction, we're going to see aluminum replace the copper here. All right, next up we have the single displacement reaction. And so what's gonna happen here, I got aluminum and some copper chloride. So if we look at the reaction, what we're gonna see is that the aluminum is going to replace the copper here, okay? It's gonna kick out the copper. And so what we should see is copper metal forming and aluminum chloride. So I'm gonna put aluminum and some copper chloride here, and let's see if we can watch this reaction take place. All right, so if you look closely, there's some brownish black metal forming on the aluminum. So if we look at our chemical equation, we'll know that that is copper. So the copper is actually forming on the aluminum. And so we can see that if I switch this around, right? So what's going on here is that we're actually forming this copper metal here, as you can see there. Okay, and that's a single displacement reaction. Next, we have a double displacement reaction. So here, two compounds exchange atoms or ions to form two new compounds. So the example, we've got C and A are switching partners here. And so we can see now that C is dancing with B, while A is now dancing with D. Okay, so they switch two different things, are switching places here. And it's two compounds, so whenever you start with two compounds, that's one way of telling. So here we've got kind of a complicated one, iron chloride with ammonium thiocyanate. And what's going on is the iron and the ammonium are switching places. And that's how we get these two new compounds. This one is in a test tube, so check out the demonstration. All right, next up we have a double displacement reaction. So I've got some clear ammonium thiocyanate in this test tube here on the left, and I'm gonna add some iron chloride to that. So let's take a close look at the test tube and see what happens when I add the iron chloride. So we get this really cool red color forming. You can see it dripping down slowly. And so that was that yellow liquid combined with the clear liquid. And we ended up with this dark red, cool color. So that's a double displacement reaction. Then we've got combustion reactions. So here an organic compound reacts with oxygen to form carbon dioxide and water. Organic just means it has carbon, okay? So here we're looking at the combustion of methane. One thing to know is CO2 and H2O are always going to be your products on the right side. And so here I've got a couple demonstrations to show you for the combustion of methane. To balance this one, you want to balance carbons first, which are balanced, then hydrogens. So we need a 2 on this side, and then oxygens last. So we've got 4 oxygens on the right side, so I'm going to put a 2 in front of that oxygen, and now that's balanced. All right, enjoy the... All right, so I've saved the best for last combustion, and so this is the combustion of methane. In order to get some methane, I'm actually going to make some bubbles. So here, this is attached to my Bunsen burner, sorry, to my gas. And so I'm just going to make some gas bubbles here, and I am going to ignite these gas bubbles. All right, so stay tuned. It's gonna happen pretty soon. All right, so again, soapy water, and I'm gonna make some gas bubbles, and then I'll be able to ignite these gas bubbles. So give me a second here. Just want to form enough bubbles. Alright, let's try this out. Want me to do it again? Alright, one more time.